Good afternoon, this is Schweitzer, and we are looking to give you some content here on alloys. Now, an alloy is kind of a newer topic that AP has decided to integrate here since the newer version of the curriculum, which is now a handful of years old. But what do we really want to know about alloys? And are you going to see a lot of problems on alloys? And the question, the answer to that question here is sometimes yes, sometimes no. I mean, they either are likely to see, one or two multiple choice questions. I have seen an occasional written question that might look a lot like an alloy, but yeah, not huge. Okay, we don't want to ignore this because if you're looking to get an elevated grade on this test, then you kind of got to be good at all this stuff. Okay, so let's take a look. So there are a couple different types of solids we have here. We have let's say network covalent. All right, this anionic compounds are kind of unique in the sense that all of them are what we would call a bulk crystal. Okay. And that is important to recognize what breaks and what's going on. So what I would like to know about metallic substances is that metallic, maybe there's two L's there, is that it also forms a bit of a bulk crystal. Okay. Now, one unique thing about this bulk crystal is that we have what's called delocalized electrons. All right, delocalized electrons. Now, when I first saw this, I mean, it's a word I've heard before, and I kind of thought to myself, what does this word mean? It means, well, local means like close to where you're at. So delocalized means, well, I guess the opposite of that. So not close. So electrons are free to kind of move between places. This is not the case for an ionic compound. Because ionic compounds are locked in spots, it is a non-conductor as a solid. Now, if you were to dissolve it in a liquid, well, then it's going to take some time and it's going to be able to move around and it becomes a very nice electrolyte. So metallic compounds are, because they have these electrons that are allowed to move, this thing now becomes a conductor. And, I could see this being a really nice multiple-choice question. You all know metals, that they conduct, but why? Because electrons are allowed to freely move around this thing, which allows electrons to pass through the item nicely. We use metals like this for a lot of reasons. Alright, so what's next? Okay, well, if we mix something into this crystal, okay, what happens? And it's pretty self-explanatory in the sense that, okay, what happens if I mix things in? And what is the number one sort of concept that I would like to consider? So what is the most important factor you need to consider when involving alloys? Okay, and it all comes down to size. Every single question, we're referring to the size of this thing you add to it. Is it big, like the other guys, or is it small? If it's big, all right, then it becomes what's called substitute. It takes a whole spot. Now, if it's small, all right, then this thing is going to wedge between them. And all you really want to know, and there are examples of these, like this is an example here of carbon. Carbon's really small, iron's relatively big. It would be what we call an interstitial alloy. This is a really common example of this because carbon and iron make various versions of steel. And the more carbon you add, the more these crystals or lines of atoms cannot shift past one another, and becomes, well, in one sense, becomes stronger. Okay, and of course, the advent of steel is what really changed the course of history to be able to make a sword. You can go and chop your neighbor down, all right, relatively easily. If you got too much carbon, then it gets brittle. Too little carbon, and man, pure iron is relatively soft, and you're gonna have a hard time keeping a nice sharp edge in this thing that you could, effectively chop something up, whether it be a tree or whether it be your neighbor. So it causes all sorts. So being able to change this ratio really helps produce different types of steels. A substitution alloy, we would not expect to have any changes in, its hardness. All right, hardness would be something that would go here. So again, steel is, if they're going to have a question, this steel is a looming thing here, as far as if they want to ask this. What about this guy? What's the difference here? So hardness is not going to be an issue, but because it's here, this tends to have some sort of changing in chemical properties. Okay, it's on the outside edge of this thing. Unlike this guy, yeah, you might see something here, but you don't see it on the outside, really. It may drop off or just kind of sticks between the molecules. This actually ends up covering a lot of the surface. So the surface gets covered, and you end up having this item can have a significant impact in how things affect it. The main one would be what we call stainless steel. Stainless steel. You can buy these guys at the grocery store, or sorry, at the Home Depot or whatever. So you can buy yourself a screw, all right, that's got stainless properties to it, which means it's not going to rust. No, not rusting. Okay. Now, in this situation, if you ever buy a stainless screw and you try and wrench on it so you take the screw, trying to wrench on it into something hard, it immediately strips out the top. This stuff is so soft. I mean, it's a really big pain to have to use these things unless it's something that's really easy to screw in. And why is that? Well, it's not going to rust. But does it have any interstitial properties that are going to cause this thing to become more brittle? And the answer is no. So are there alloys that would contain both? Yes. Now, that being said, if you have a metal, all right, that has both, you can make a screw out of it, that has both ability to be hard and not rust, well, that's going to be pretty valuable. And it may not be any more difficult to make, but the price on this thing is going to be driving up just because it's more valuable. Okay, so here's some examples of alloys and interstitial, substitutional. The main thing here is size and how the crystal sets up. Okay, thank you very much. So we'll end here for today. I'll flip it to the next screen just so you can see my answers on this thing that I had. Okay, that's all.